We've drawn quite a number of great circles on stereographic and equal area projections. Sometimes we have a need to draw what are called small circles. I'm going to show you when that need arises. Here's a page from our online manual, and here you can see a diagram of a piece of drill core with some veins cutting through it. And those veins are at an angle to the drill core, but because the core is not oriented, we don't know how it was oriented when it was in the ground, in the hole, we don't have complete information about the orientation of those veins. So all we can measure is this angle, the core pole angle, or this angle here, the core vein angle. So we're going to use the core pole angle, and what we can say is that the pole to the vein must lie somewhere on this small circle that is centered on the orientation of the borehole itself. So we're going to try to draw a small circle with a given orientation that will show all possible orientations for this vein. And I'm going to use numbers for this purpose that are drawn from an assignment that we have in our class. It's in Lab 6. I'm sorry, Lab 7. And we're going to do this as before in PowerPoint. Now, we've looked at a number of different plotting methods in PowerPoint. We've looked at this Schmidt net, which is used for equal area projection and is the net that you have to use when you are doing something statistical on the projection. And we started looking at this wolf net, which has a very simple mathematical construction. And one of its features is that all of the arcs on this net are circles. And in fact, a property of the stereographic projection is that any circle, whether it's a great circle that divides the sphere in half or a small circle with a smaller radius, any circle projects as a true circle on the projection. So in this case, we're going to try to plot the orientation of this borehole, which is 340 trend and a plunge of 70. And northwest is redundant there, but it's just provided to be helpful. We first need to rotate our net, and I'm just going to do it freehand here, rotate it to the 340 position. And then I'm going to take my marker. I'm going to need several more markers, so let's make a few of those first before we start. There we go. So I'm going to take my marker and I'm going to drop it on a trend of 340 and a plunge of 70 degrees. And that position is down here. Let's adjust its position with the arrow keys so that it's nice and precisely on that intersection. So there's the plunge and trend of our borehole. Now what we need, we know that our core pole angle is going to be 50 degrees. So we need to make some more points that are 50 degrees away from it. So 10, 20, 30, 40, 50. There's a good one. We could put one there. And we could put one 50 degrees the other way. 10, 20, 30, 40, 50. So we could put one just here. And we're going to need a third point because you need a minimum of 3 points for the general case to plot the small circle. So let's take another one. And to do this one, we're going to need to put this starting point on a different great circle. So I'm going to turn the net around. I'll maybe turn it about 90 degrees to here. And this time I'm going to place a point 10, 20, 30, 40, 50. Now I could have taken a shortcut here and just gone halfway between these 2 points and used it as the center of my circle. But I want to show you the general case for plotting in any orientation here. Now I'm going to draw some lines. I'm going to draw some lines that connect these points, all of which are 50 degrees away in three-dimensional space from our starting point. So here we go. We're going to draw a line from the center of this one to the center of this one. And we're going to get another line, which we're going to draw from the center of this one to the center of this one. So there's a geometrical technique for constructing a circle going through 3 points where you have to find the intersection of the bisectors of the lines joining the 3 points. So we're going to do that. So I'm going to take this line here, and I'm going to, in my arrange menu, in rotate or flip, I'm going to do rotation options. Actually, all I need to do is rotate it 90 degrees. So I'm going to rotate it 90 degrees. There it is, it's rotated 90 degrees, and I'm going to do the same with the other one here. Arrange, rotate, doesn't matter whether we go right or left. And we need to make those two lines intersect. So this one I'm going to have to make it longer. So I'm going to hold down the Shift key, and that will mean that I'm constrained to extend that line, keeping its direction constant. So you see these two lines intersect, and they intersect at a point which by definition is the center of the circle that goes through these 3 points here. You'll see it is actually halfway between these 2 points here, and there's another way we could have done it. But this 3-point method works for any 3 points on the small circle. So that's going to be the center of our circle. So this is the trick we have to deal with, that the center of the small circle on the projection is not the same as the center of the small circle in real 3D space. So to make my small circle, I'm going to go into shapes again, and this time I'm going to grab a circle shape. And I'm going to click on the intersection of these two lines, and I'm going to drag out a circle. Now, as I first drag out a circle, that's not going to work for us because it's floating off somewhere to the right, and it's also an elliptical shape. So if I hold down the Shift key, that will constrain the circle or the shape to be a true circle. See that for some reason I have to drag to the top left or the bottom right. It doesn't work if I drag in any other direction. That's just a peculiarity of PowerPoint's construction tools. And now I'm going to hold down a second key, the Control key, and that forces the circle to be centered on the place where I first clicked. So then by dragging this circle, I can stop when that circle passes exactly through those 3 points. There it is. And I may want to make that circle hollow by turning off the fill, and I can do that in this drawing menu here, shape fill, no fill. So there you have a small circle constructed on the projection that passes through those 3 points that we constructed, and the radius of that circle is 50 degrees in 3-dimensional space. I think I can just improve it a little bit with the arrow keys by jogging it down a little bit so that it splits any error that we have between those three. And there we have a small circle centered on a line of known orientation. And that gives us all the possible orientations for that vein that we intersected with our drill hole. If we had a couple more drill holes in different directions, we could draw small circles for all of them, and then by elimination find out the true orientation of the vein.